This is a good time for us to get started. So let me start by ending polling and share the results so all of you can see what everyone's doing. I think most of you have spent about an hour, and some of you have spent a little longer. I can definitely assure you that spending a little bit more time early on is probably a good thing. Don't wait till the lab is due to try to cram everything together. Okay, and the real reason is that everything we do in this class will be useful. Nobody was bold enough to say 0. That's a good point, though. Maybe there were some zeros there. But like I said, the purpose of this course is to give you tools that you can use going forward. So rather than trying to learn it on your own, this would be a good time. You have someone like me to help you along, and your class, other people in the class. So it's a good time to pick up all this stuff, okay? Okay, so let's get started. I have 2 things to do. The first thing is probably spend some time talking about NumPy, but I wanted to also maybe briefly go back and recap what we talked about on SQL. So I don't have a poll for this. How many of, I don't know how to ask, how many of you would like me to briefly recap what we discussed on SQL? Yes, please. Okay. A lot of you want it. Okay, so let me try to do it slightly differently today, okay? Just to give you, on the course page, I put some notes. So let me walk you through this, and then we'll go to the notebook and look at some things as well, okay? So if you follow me, you go to session 1 on the course website. There's a section on databases, section 1.1. If you go there, I mean, there's some links in here that you can explore if you're interested in databases. But the long story short, it is a amazingly powerful tool. And the last 20 years have made databases central to many, many large companies. And so if you end up doing data science or data analysis anywhere in large companies, some amount of the data will be in databases. And so it's nice to be able to get data out of a database, right? But the main idea that made databases in such a big focus was outlined by Code in this paper that I've given a link to. It's an amazing paper, and if you have the time, you should spend some few minutes reading about it. But his big idea was that unlike files, when you work with a database, you don't have to worry about exactly how the data is stored. The database will take care of it. And all you have to worry about is the idea of a table, for example, right? And a table is, you can think of it like a square, like a n rows and m column structure, right? An n by m structure. And today when we do NumPy, we're going to spend a lot of time on that as well, right? So the first idea is you abstract away the details of storage. And you process the data independently of how it's stored, right? So that's a big win for us because you can add columns and add rows without breaking anything. Then when you do this abstraction, you get rid of the dependence of order, you get rid of the dependence of what index is on the table, etc. Those are all kind of good things from a software development side, right? And now you come to the idea that in order to do all this, we have some language in which we can work with the database, and this language is SQL, right? And what we were trying to do in the class, which I'll get to in a second, is how can we write SQL commands to query a database, right? And essentially, there are 2 types of SQL commands, DDL and DML. One of them, DDL, is used to define things, like define a table or define an index. And DML is used to modify things, right? So you want to update records, insert records, etc. And this is a nice little acronym, CRUD. So typically your activities fall into these buckets, right? Either you're creating records or you're reading stuff from the database, you're updating records, or you're deleting records, right? And delete is the thing we want to do the least, or should be doing the least, but the other stuff is bread and butter work for anyone working with a database. So that's a kind of heuristic of this, and there's a kind of map, right? If you're saying create in SQL, it becomes an insert. If you're reading, it becomes a select. Update is update, and delete is delete. So the nice thing about SQL is that it's as close or almost as close to English as possible. Okay, then here I just spelled out something that we actually want to write code around, which is to make this database to store information about students, the courses they take, and the grades that they have for activities in that course. So this is kind of a fun thing that you should do. Probably not the best thing for me to spend a lot of time talking about it, but for you to look at it and understand. So usually there's a big fat flat table like this. This looks like an Excel spreadsheet if you want, but you can see immediately that this has many flaws, right? From a flexibility perspective. For example, if I want to change the name of a course, it's all over the place. So you have to change it in multiple rows. If a student's name has been entered by mistake, then you have to change again in multiple places, right? So this data structure, even though it is one table and looks fairly simple, is actually very brittle from a data perspective, right? And so what we end up doing is creating a data design. So let's go back here and say, okay, how would we do better than this one table? So this is the stuff that you should do quietly when you do your practice, right? Take down the columns from this table, try to foresee what kind of problems could happen. And you should do this all in a exploratory way, right? Usually what happens is people go through weeks and months of building applications and learning from the pain of maintaining something like this. Here we want to avoid creating the problem in the first place, right? So try to learn the concept as quickly as possible, right? So here's the idea. So the way to get around this is to end up with a slightly different structure. In fact, maybe I'll just flash the structure on the screen. If I have it somewhere, let's see. Maybe, yeah, it's here below. So in that one table gets replaced with multiple tables, right? And this is called, this activity is called normalization, right? Normalization means to take one big fat table and split it into multiple tables with a view of making it more maintainable. Maybe it's slightly more complicated, but actually it makes life more maintainable. So let's see, what is the process of doing this? This is database design, right, in a nutshell. So first you find all the kind of nouns in your problem space. For example, this is a student grades database. So there are students, there are courses, and there are grades. And these are the main tables. So eventually you end up with a students table, right, a grades table, and a courses table. So you have 3 tables. And now you need to ask, how can I connect these tables? And the main ingredient in this is asking the question, what is the relationship between the entities? If they are one-to-one, then you would probably have a direct link from one table to another. If they are many-to-many, you probably have a mapping table in between. Now, this is not an intro to SQL course, so I'm not going to spend time on modeling. But if more of you have questions, we can spend more time on this, okay? So this is kind of the design that we have kind of ended up with. I did this all, kind of created it for you to give you a mildly realistic example. In a real world database, like in a financial database, there could be 50 tables or 100 tables, right? So it'd be much more entities and much more relationships between them. And learning to navigate such structures would become essential if you're working with any kind of large scale database. So, okay, so to do all this, what did we do? We created we had a notebook here. So for those who are new, you can just click off this link and then you'll end up on a page which looks like this. There's a login at the top, so make sure you log in. Make sure you clone the database and then you can run this, right? So I'm going to just do that. And then, okay, so, and then we can just go to the notebook which says Intro to Databases. I added a little bit, so if you want, you can reclone it. But essentially now I'm just going to talk you through, some stuff. And for those who are already seen this, it's just a recap, right? So nothing very complicated here. The most important thing is that we're using SQLite. So we actually have a database that we can control easily. So that should give you a chance to practice. And maybe you can even use it in your project when you get to making a project, if you want to put your data in a database, okay? I'll show you some other options later as well. So the simplest idea here is this 2 lines here. That's what drives the whole thing. Well, of course, there's imports here. So the most important import for this conceptually is to use this package, SQLite 3. You import that package and then you're ready to go. And then these are the two main database related things, right? You specify a connect command, give a path to the database, and you can open a connection. When you're finished with your work, technically you should close the connection, okay? So that gives us a starting point. We have easy way to connect to the database. So you can run all this code while I'm talking in the class, right? So you can connect to the database. As soon as you connect to the database, if you have a valid connection, you can ask the connection to give you a cursor. And a cursor is the object with which we do all our work, right? So we take a cursor and we get all our work done using the cursor. For example, the cursor is able to execute any kind of SQL command. So this for you is a nice playground to practice writing SQL queries and seeing what happens, right? You don't need a big database or a complex setting, okay? So what do we do here? For example, the first example is the simplest one. We create a table, right? And this if not exists in here, even though it kind of makes this query a little bit more complicated, actually basically checks if the table already exists, so that you don't try to create the table twice. Because if you try to create the table twice, then it will fail, right? Because it already exists. And then you can proceed, right? You create the table and you proceed. You can use insert commands. So here is the actual insert command here. And I'm going to insert multiple students into this table, right? So each student's information I've stored in this tuple, and you can pass this to the cursor in a loop and insert all the students, okay? Now we talked through this in great detail last time, so I don't want to beat this to death, but please do walk through this. The hour or two that you spend is to basically, you should delete this code and create it on your own, or look at this code and make sure that you understand everything. And because it's working, please don't confuse yourself into thinking that you understand everything, right? Because I've written it, I've taken care of lots of small things. So when you erase it and write it on your own, you'll probably have questions and understand a bit more. Okay, so we did insertions, but since we are reviewing stuff now, I want to go briefly. I think I have put it into the notebook now, because last time, let me see. Yeah, if you can all follow, I'll tell you where to get to. Yeah. So if you scroll down enough, you'll see that I inserted a new section called joins, because last time some of you had said you're not so familiar with joins. I don't want to again make this into a database course, right? So I'm going to just take like 5 minutes and talk about joins. The main point here is that when you have two tables, you can think of it as a table on the left and a table on the right. And you want to join them. The activity of joining them is basically, first you have to find matching records, right? So there has to be some criteria of how to match a record from table 1 to table 2. So for example, if the left-hand side, let's do it in a simple way for now. If the left-hand side is a table of students and the right-hand side is a table of courses. And for now, let's just assume, even though poorly, that the relationship is 1-to-1. So we don't even have to worry about it. But you have to know which student is in which course. And so there is a link between these two tables, and that is done through a key, right? And it's usually called a foreign key. So for example, you can either put the course ID in the students table or the student ID in the course table, right? So that key is used for me to do a lookup. Again, I'm going fast, so stop me if I'm saying anything that's not easy to follow, okay? If you already know this, then everything I'm saying is kind of trivial, okay? So if you don't know it, just stop me and I can spend some time, okay? So anyway, so what's the idea then? Two tables, each table has a key, right? A primary key in it and a foreign key from the other table, which tells me how can I look up the matching entry in the other table. So that is one of the important ingredients in trying to connect or join two tables. The next ingredient is this idea of 3 different types of joins, right? So there are things called inner joins. Inner joins, all of them have their flavor that only matching records. So think of them as 2 sets. Only if there is a match found, those records will be returned, right? So those would be inner joins. But when you do inner joins, you can see that there's the notion of a left inner join and a right inner join as well, right? So left inner join says return all the records on the left along with everything that you can match. So it's a little bit bigger than just a straight inner join, which returns only matching records, right? So left inner join will give you a little bit more. And then there are outer joins, which return everything. So for example, in SQLite, there's the notion of a cross join. But the cross join is a very ugly beast. It returns for every element in the first table, it returns all combinations with the second table, right? So if there are n records in the first table and m records in the second, you'll get n times n records, which is very large. Okay, so that at least gives you, if you don't have to memorize any of this, right? So the idea that we are doing a matching between the elements of two tables, we will use some kind of criteria to look up the entries in the other table. And then we have to decide what to do with records that don't match, right? Do we return them or not? That is the main conceptual underpinning to this whole discussion. So one of the things you can do, I just kind of mock this up here, right? So if, for example, if the left table was the students table, so you just find out the name of the table. So here it is. The name of the table is called students, right? And the ID is called the student ID, right? So now you can ask the question, if you want to join with the student in course table, what should be the values in the right table? Of course, the name here would become student in course. And now you have to go and find which key shall I use. So essentially, that's all you have to ask, right? Which are the tables and what are the keys? Once you have that information, the join query becomes very easy. So let's look at this. So we are joining the students table here, students table with the student in course table. And the key we are using is ID student and ID student. So in one case, it's the foreign key on the left-hand side. On the right-hand side, it's the primary key. So we are matching on this key. So wherever this key matches, those records will get returned. And that's all it is, right? So it's a fairly simple thing. You first fix which are the tables, then fix which are the keys, and then you decide that whether you're doing. In SQLite, it's primarily inner joins. And I think in general, in most cases, inner joins are the ones which we want, because that's when we have data on both tables. When you don't have an inner join success criteria, then you get blanks from the other table, which you then have to manage. So inner join is always the nicest case. So then the rest of this is all about more and more joins, because there are, half a dozen tables in our database. There are many other joins you can do. So if you just use this notebook to do a lot of the joins, then I think you'll be in good shape, right? And so what are all these joins doing? These joins are saying, look, I would love to have a flat structure like the starting table, but I would create that flat structure when I need it. When I need to make a report or run something, then I would bring things together. So the actual storage is done in multiple tables, and it has all the goodness of splitting things into multiple tables. The data is not replicated. It's easy to granularly update things, etc. But I also have the pleasure of bringing things into one tabular structure by joining all the stuff in the database. And if you can do this much, which I've said in a few words, and I think there's plenty of stuff to practice in the notebook, then you're conversant with SQL and SQL databases, right? You know how to create the tables, you know how to join stuff, you can pull stuff. And then the last part becomes just writing reports, okay? So that's in a nutshell. Any questions? That's always tough when I ask for questions. How can you update cloned repos to be like your updated version? Unfortunately, I don't have a good answer to this. It seems like the practice is to just make a new clone. But if you really don't want to do that, then you can, I don't know, you can, probably the best thing is to make a new clone. Don't make your life hard. This is probably the easiest thing. But if you need more help, send me an email, okay? We can discuss. Okay, so let's switch gears now. Considering, no, I mean, okay, somebody asked this question about, does it require you to learn SQL? I don't know how to answer this well. You're not going to fail this course because your SQL is not strong. Okay, there'll be a couple of things that will ask you to do SQL. But if you're interested in data and data analysis and you want to do something in data science or anything like that, right? Or even become a strong software developer, or even run a company where databases are integral to them, then it's probably worth spending a little time, right? So that's what I would say. Actually, so I don't see this lab. Somebody was asking me also this question. So there are no labs. There are no labs that should be due. Let me check up after this class. Can you point me to the link? Then I could look at it now. But otherwise, I'll send an email after this class. Can you? I don't know. Maybe. Oh, there's a data persistence lab. Okay. So yes, yes. Okay. So yes, I remember now. So okay, I will extend the date on this lab. Okay. I plan for you to do this lab. So let me send a note out. I'll give you like 2 weeks to do this lab. Okay. This lab is a combination of this week, of last week and this week. So I'll give you some time to do this. But this lab will basically ask you to essentially repeat everything that's in this notebook, right? Do some of these queries and submit it. That's it. So I will send the dates out. Okay. I'm sorry, I didn't check the dates, but yeah. But no harm for you to go ahead and look at it and see what's in there. Okay. And let me know if you have any questions as well. Yeah, thank you. That's a good question. I'm sure everybody had this question. Okay. So then, yeah, so just to finish up the thoughts, I think for all of you, SQL is an amazing way to model data. And so if you're working in data, even not with databases, I think learning a little bit about SQL is going to be very helpful to you, okay? So please try to make that investment in yourself. But from a course perspective, not all of the course is centered on SQL. I think in this data persistence lab is the one place where you'll see a little bit of SQL. So if you can finish this lab successfully, you've got enough. And if you need help, just let me know. Okay, so let's switch gears now and go to the topic of today, which is introduction to NumPy, right? So let's start here and start with the web page quickly. So NumPy is, I had a poll here, let me see. How many of you have used NumPy before? Maybe I would love to know that. Okay, how well do you know NumPy? Maybe it's here. Can you take the poll here quickly? Okay, so some of you have used it, some of you have not used it before. Yeah, it's kind of a split here. So that's what I expected as well. So let's just start off by saying, okay, we'll just say, okay, what is NumPy? Why do we need it? The main idea here is that we are going to do a lot of data manipulation and sometimes very large data sets, right? And if there are large data sets, how do we manipulate them and yet get a lot of performance, right? And the answer is an old answer. It starts with creating a good data structure to store the data in, and then to have small library functions to manipulate this data structure. And what is interesting here is that you will get a lot of performance if you use NumPy compared to using raw Python in many cases. But you will also have to learn some things and change the style of programming a little bit. So rather than giving you any theory, we'll go straight away to the lab, to a notebook and write some code. Okay, and I'm trying to make this course as interactive as possible. Okay, so maybe I will skip over this thing about NumPy features because I'm just going to be talking and we'd rather write some code, right? I assume that is true. How many of you prefer when I explain things in words, and how many of you like code? I wish next time I have to ask this in a poll, I guess. Someone on chat? Practical is better. There you go. Okay, yes. So let's go. So if you go to this section 2.12 and click on this link, it will bring you to a page which looks like this. And then again, the same thing, clone the repo and then hit run, right? Click the run button and then you're ready to go, right? So now you can just open this notebook called Intro to NumPy. Okay. And as soon as you open this notebook, I think right away, let's see, it'll take a minute to load. So make sure all of you are here. You can, I have some questions for you to do in this class. So maybe you can type some code. Okay, so there's a quick programming challenge here. Let's see. So the beautiful thing here is two things. I emphasized performance, but I think the other thing which is really important is we can take an idea and make it into working code in a couple of lines. And so today's class is all about those two concepts. How can I translate some idea into code quickly? And when I have written the code, how can I make sure that it can work fast? So let's try programming challenge 1. Write the code to create list of 1,000,000 random numbers in the range 1 to 6. And compute, I've just picked 1 over x for each of the x's in the list, right? So can you think, can anyone type the Python solution in chat? I'll give you a minute anyway, right, to think about this. If you don't have the code that you can paste in chat, at least you can tell me how you'd approach it in chat. Like you could tell me you'd use a for loop or a while loop, or how would you think about this problem? Okay, at least tell me, is the problem look easy? Anyone who thinks it's easy, anyone who thinks it's hard? One member from each group at least. Let me know in chat, I'm watching chat. Use range, okay, that's a good thing, yes. Use range. Notice that in today's class, I'm going to use always big values for range. Yeah? In this case, we're talking about 1,000,000 numbers. Okay, so that's a beautiful idea. The range becomes a powerful workhorse for us in Python, right? Okay, so anyway, I won't spend more time. I'm going to start showing you the code. I've left the code on the screen for you. So there are two libraries we'll use here today, NumPy, and then there's the random number library in Python. We can use it sometimes as well. NumPy has implemented everything. So NumPy also has its random number generators. We will use both of them periodically. But before we go further, I want to tell you something interesting about Jupyter Notebooks. Very often we want to know how performant our code is, right? And today I told you I'll show you some performance things. So for example, to take 1,000,000 numbers and compute 1 over x or something like this, how long does it take, right? And if you have a guess, you can guess. But the amazing thing for all of us today is that with the power of our computers, this kind of thing will take hardly a couple of seconds, right? So I want to show you now some nice Python code. So the Python code uses range as I guess it's Casper said. So range, so you create a range object which has a size 1,000,000 in it. And then you use a for, right? You iterate over the range. And once you iterate over the range, each time for each element, you can generate a random number in the range 1 to 6. Okay, so this will create a list, and then you can use this list to compute what we are supposed to compute. So we are supposed to compute 1 over x. So I create a lambda function. Notice I'm going fast with the Python code here. If some of you are not that strong in Python and this code is not clear, you can always send me an email, okay? But of course, I want to tell you that the code which is written well will look like this. It will take only 1 or 2 lines to do something like that, right? So here's a lambda which computes 1 over x. That lambda gets mapped over the list in question, and then a sum gets computed, and you're done, right? And if you actually run this code and look at the timing, you see that it takes about 5 seconds. Okay, so this time it function is kind of useful in Jupyter. It runs it 7 times by default. You can make it run more or less, and then computes an average. So you have always a way to keep idea what does the performance of my code look like. Okay, now you switch gears and you do the same thing in NumPy, right? And the idea is that NumPy has its own random number generator, and it takes a low value and a high value, so 1 to 6 just like before, but it interestingly takes a size parameter. And notice that I can just pass the size parameter to NumPy and eliminate one for loop. And so part of the story is all about for loops are nice and easy to understand, but they're also slow. And so sometimes people can optimize things, and eliminating for loops can get us performance, right? So for is most explicit, but not most performant, right? So NumPy actually says, don't worry about for loops and everything. Just tell me what you need and I'll give it to you in one shot. And so the first thing we do is we generate 1,000,000 random numbers in the right range. And then NumPy says, you want to take 1 over x, but this is 1 over x for all elements in a list. Nums is a list now. You just do 1 over x and it automatically computes 1 over x for each element in the list. And we're going to discuss this in more detail, but this is an example of what is called a vectorized computation, right? It operates on a vector or a list and performs that operation for each element on the list. So you don't have to do it with a for loop where you go through using a map or a for loop and apply it by yourself, right? NumPy will take care of it. And NumPy has this, this is like a Python sum, right? So, but it's a faster sum. Aren't they all linear? Okay, so that takes us in a whole different direction. The reason why it's not necessarily linear in some cases is because you can manipulate an entire array in memory instead of looping over it, right? So there are faster operations, but they're very low level operations. So you implement that kind of code using pointers in C and even some Fortran code and so on, right? So the low level operations can be faster. For line 3, it produces a name error code. What is line? Did you do the import statement on line 2? I think somebody was at, okay. Yeah, I think someone is having problem running the code. Okay, so that's one of the sad things about the notebook, okay? If you're running this, you must make sure that every cell is executed. Yeah, so just make sure you run the first cell, then you run the second cell, okay? Okay, so you can get some significant performance improvements. And look at this thing, even though it doesn't highlight it, that was 5 seconds, this is in milliseconds. So it can be 1,000 times faster. It can be easily 100 times faster, okay? And the explicit reasons, you have to go case by case and see. So if you're interested, I like performance details, you have to go and see which allocation and which operation got faster, okay? Okay, so you can continue like this, right? But let's try one more example. Here is a quick programming challenge. By the way, this is a metaphor, good metaphor for all of you to, when you spend your time practicing, take a problem like that and try to solve it. And if you don't have problems enough, ask me. You'll have labs and things soon. So it's not like you don't have enough things to try. And of course, in the class, I'll give you practical things. And just think about how would you solve such a problem. So I'm saying here, create a list of the first 100 integers. Later, you can change 100 to the first 1,000,000 integers. Create a list of the first 100 integers starting with 1,000 and compute the sum and square it and then compute the sum of the squares, right? So you look at this kind of thing. Okay, it's kind of a little bit of an artificial problem, but it's interesting, right? So you try to do it. And of course, when you learn programming, the first thing you would try to do is write a for loop for this. As you get more powerful, as I've shown some examples here, you can see that you can actually do this. Again, I use map and sum. So the map and sum becomes like a metaphor for this kind of operations, okay? It's a subtle question as to why map and sum can be faster, okay? But we won't go through this today. Here, just I want to get you to NumPy, right? And the point here with NumPy is look at how cool that solution looks in NumPy. You create L1 and L2 as vectors. You add them as vectors, not as elements of vectors, right? You just say, just add L1 and L2. As long as their sizes match, NumPy will figure out which index to line up with which index and all that stuff. So this, I really want all of you to appreciate. Your code becomes much easier to write and maintain and reason about, right? If you want to add the first element of one vector with the first element of the second vector, normally you have to do some index gymnastics or more work. Here you don't have to worry about it, right? NumPy vectors can be added easily. And that makes the logic look very much like the logic you would see in a statistics book or a math book or something like that, or linear algebra book, right? So your code will look very much like the mathematics. So you add the two elements of the vectors, you take a square. Notice the square is also done on the vector itself, but it means element-wise squaring, and then just take the sum. Okay. So again, you'll see if you play with stuff like this, you'll see that all of these things not only look nice, but are really powerful, really fast, right? Okay, so quick summary then. Fast operations, fast vectorized array operations, that's the main goal of NumPy. Common algorithms, right? You'll see later there are sorting operations, set operations. There's an entire library for you to manipulate these arrays, and those manipulations are optimized as well. Descriptive statistics easily available. So asking for mean, standard deviation, correlation, those are all going to be like one-line commands. Then instead of using for loops, you use array-based computations, right? You've already seen a couple of examples. Then you're going to see later you can do all these things like aggregates and so on, right? So you can, for example, sum is an example of the simplest aggregate. I think that's enough for now, but there's more, right? Fourier transforms, linear algebra, there's a lot of mathematical libraries that have been built for us already on top of all this. Okay, so that's all background. Now let's get started with the hard work. Okay, so let's start by saying, okay, I'm sold, I want to use NumPy. So how do I start, right? What do I need to know? So I'm trying to give you a basic toolkit. So the first thing you need to know is how to create NumPy things, right? NumPy, let's work with one-dimensional arrays for now, right? So the easiest way to create a one-dimensional array. Okay, so maybe I have to actually take a step back and do some Python here. How do you create suppose, okay, so somebody can tell me in chat, if I ask you to create a list of, of length 100, don't worry, 199, but length 100, and maybe populated with all the numbers from 0 to 100. How would you do it in Python? Somebody wants to type half a line of code in chat? Share it with the class. You have 30 seconds. If you're not typing, you should be thinking how to do it, okay? The answer turns out to be surprisingly simple. Okay, so let me type, okay? So the idea is that you first use this range object in Python. This is a workhorse, and you specify range Linspace. Linspace is already NumPy world, right? So I'll show you Linspace in NumPy in a minute, okay? So let's do the basic thing first. This is plain Python code, by the way, okay? I'm not using NumPy or anything. If you say range 10, it gives me 10. It's a container. It contains 10 elements. You have to extract them one by one. But it starts from 0 and ends with 9, right? So, but if you want to be explicit, you can do 1 comma. So if you want to start from 1, you can do 1 comma 10, okay? Now to convert this into a list, there's a nice thing. There's a list constructor you can use, and you can say, please make this into a list for me. So you should all type this and run it and see. This is a quick way when you're learning Python to create different lists of different sizes. It might be the shortest way in code to do it. So I use this all over the place, okay? So now that I've told you that, the idea is that if you have a regular Python array, you can just pass it to np.array, and NumPy will take that thing and convert it into its internal array representation, right? So once you've done this, now this thing is a NumPy array. It's not a Python array anymore. What I first showed you, that what is passed to this guy is actually a Python array, okay? So make sure you run it and check it, okay? So now that's the easiest way. Take any Python array, give it to NumPy, it'll make it into a NumPy array. So that is one way to do it. Another way is you can just ask NumPy, can you please create an array for me? So just like range, NumPy has a function called arange. And range, if you know how to use range well, you'll know that it has 3 parameters. It has a start parameter, a stop parameter, and a step parameter. Usually the step parameter is left out because we want to step in steps of 1, but you can go in steps of 2. So for example, if you want to create even numbers, you can start with 0 and go in steps of 2. So just play with this a little bit. It's always good to be able to create our arrays quickly, okay? So we can play around with them. So, okay, so NumPy can do this thing without using a Python. So if you wanted to create an array from scratch, you don't have to use Python. You just ask NumPy to do it. And NumPy says helpfully to us, well, I'm going to look very much like a Python range query, but I will just do it better and faster. That's it. And then you can also say, like, so the point here is, which I want you to now start appreciating is, just I showed you how to create half a dozen numbers, but you can create a million or a billion sized array in a flash, right? Our computers are so powerful that you don't even have to think before you create a million sized array, right? So this was not the case even 20 years ago, right? So very cool for us. Okay, so that's one kind of thing. Then now there's a bunch of utility arrays. So one of them is, sometimes you want a list with only ones in it. So you can actually have a list which looks like that. So you do np.ones, you pass how many ones you want. So in this case, I want 5 of them. If I wanted a million of them, I would pass in a million. But what is interesting I want to introduce now is that these arrays are typed arrays. So they actually, for performance reasons, an integer has a different size than a float. So by controlling the D type or the type of the elements of an array, you can actually make the size of the array more optimal. Okay, so that is also a nice thing. Okay, so you can play with this. So you have ones, you have zeros, you have full. Full is, okay, maybe you use it. But now the interesting one, let's spend a minute on that. This is the one which is called Linspace. Okay, so Linspace is where, and somebody had mentioned on chat Linspace, right? Linspace is very cool for us because it allows us to create equispaced, quote unquote, linearly spaced sets of numbers. And it works just like range look like, right? You have a start value, a stop value, and a spacing value. But it behaves differently. In the case of range, it was, here it will take 1 and 10 and divide it into 5 equal pieces. And this will be the boundaries of those 5 equal pieces. Okay, so again, I would advise all of you, not much I can say in words, unless you have a question, play with Linspace, right? And once you get used to Linspace, you will find Linspace is extremely useful, right? Because for all kinds of things, like to plot a function even, the simplest way to plot a function is to create a Linspace array and then pass it to the function and plot the y values and the x values. So these are all useful tools when we want to do some work. Okay, so but right now our job is just to know all the tools so then we can actually do some work. Okay, so then let's do a small problem. Why don't we, okay, so let me say something to preface this. One of the nice things that we have with this course and this tool set is that we could actually explore the world of data by making simulations, by making the computer do some work for us, and then we can stare at that and try to learn how does it look, right? So for example, if somebody told you, can you flip a coin 100 times or 1,000,000 times? No, normally that would be impossibly hard for us to do, right? It'd take a lot of time and energy. Here you can do it in a couple of lines, right? So this is a very nice thing for us to think about whenever, hopefully this course will make you start, whenever you have a problem, you say, can I simulate it and find the answer? So let's look at it. I want to simulate a coin. So there's a very nice function. This is a random number function called choices. That's a Python function. It's in the Python library. If you give it a list, in this case, I've given it heads and tails. Somebody else has name error. Okay, so I don't know why it is there. Are you running it all the way from the beginning though? Can you try that too? Someone else asked me this question earlier. So please, if anyone's having trouble, just start running the code from the top of the notebook, right? I don't know what the name error is. If you still have this error persisting for you, can you take a screenshot and send it to me? I would also say sometimes just make sure that you followed the path correctly. So a couple of things to debug. I don't know if you're having an error in the notebook. Is anything running in the notebook? That might be the simplest way to troubleshoot this. So I'll just spend a minute on this since all of you are using the notebooks, and if there's problems. When you go into a notebook, just type like 2 + 3 or something and just see if Python is even running, right? If it doesn't run, then it means that something is wrong with the notebook, right? Like in my case, maybe right now. And usually what can happen sometimes is that the kernel behind the notebook can time out. right? So if the kernel has timed out, then there's nothing we can do except restart the notebook. Okay, in my case, I'm lucky. My notebook is actually running, you can see. So, right, whatever, 2 plus 3 is 5. It actually ran. So first make sure that a simple command like that will run. If that is okay, then the next thing is to make sure that you're running all the cells in order, right? You have to make sure that the import is run before you can run the next one and so on and so forth. So can you try that in chat and let me know if it's still not working? I think if at the worst case, you can just go to kernel and say restart kernel and then start all over again, okay? And then let me know if basic Python is running, like 2 plus 3 is working, or it's something else, and it's working. Okay, so it looks like some of you all, by the way, that's a known feature and bug of Python, right? That it allows us to run the cells out of order. You can go to any cell and try to run it. Yeah, I'm tempted to just hit run on this cell, but I really don't know if it's going to work or not. In this case, I could run this cell, but it worked because it didn't depend on something else. Okay, so all of us will have that problem. Just follow the tips I gave just now about how to debug yourself, right? If something is not working, always first make sure the notebook is running by running something simple. Then you think it's an order thing, so then start from the beginning. Okay, good. By the way, that is a very important thing, hard for me to teach, but it's a very important thing for all of you as we are working with computers. Things will break all the time. And rather than getting frustrated and panicked or worried, we'll just take a deep breath and try to figure it out, right? And so anyway, that I can give a long lecture about debugging things, but it's a life lesson. We learn from programming that things will break and we handle them calmly. And we bring that lesson into life. When things break in life, we try to handle them calmly too, right? Okay, so let's continue here. So we wanted to simulate this coin. So we go to random.choices, and choices takes an array. In this array, I've put the 2 possible values that I want simulated. And I can tell how many simulations to make. So I want 10 times to flip a coin. I can just say random.choices this way, and I'm done. Okay? And immediately you can see there are a lot of things you learned in probability and statistics. When you have machines that can simulate stuff like this, you can do quickly. So for example, if you wanted to check if this coin is biased or not, if this random number generator is biased or not, you can quickly check the average number of heads and tails and make sure that they converge to half. So it's a fair coin, right? So those are all nice things. So you can test all the ideas that you learned in statistics by writing some code. So it's a beautiful way to learn and practice doing some analysis. Okay, Numpy also has the same thing. It looks very similar, so I'll put it side by side, okay? But it basically, okay, it does the work better and faster, that's all. So in some cases right now, rather than showing and demonstrating, I'm just going to say it does it better and faster. But the goal for you is to know how can I use Numpy to do it, okay? And the idea is that in many cases, especially when you're working on professional projects, you'd rather take the performant answer, right? And in some cases, you might want to compare Numpy with Python and decide, okay? Okay, so the next thing is simulate 10 rolls of a 6-sided dice. So that's an interesting one. Again, it looks, if you look at a problem statement, that looks a little tricky, right? The normal dice that you roll. What does D type mean? Okay, so this is a very important, good question. Thank you. I'll answer. D type is basically saying that the elements of an array have a type, okay? And usually the elements of an array that you know are integers, floats, etc. Okay, Numpy has a special set of D types. So we'll talk about this D type U1 in a minute, okay? But keep D types for now at the back of your mind. The idea is that every time there's an array, it has some kind of type. It's either integers or floats or booleans or something, okay? Okay, so I will give you the simple ones. We'll talk about U1 and things like this later, okay? For now, just think about, so here I'm explaining something about D types. So let's just look at it. Main D types are integer float, integer float, bool, and complex numbers, right? These are the ones you want to use. And then you have different flavors. You have the 8-bit, 16-bit, 32-bit, 64-bit type of integers. They just allow us to store bigger and bigger integers, Okay, so that's what I want you to focus on now. Don't get into U1 for now. Okay, just think of integers, floats, bools, complex. Enough for us right now. Okay, so bear in mind that here, for example, if I do np.arange and I want floats, I can make them floats, right, by saying as type. So you can convert from one type to another. Okay, if you want to convert. So you can say as type integer and it will convert it to integer. So you see that's a float array here and that's an integer array here. And of course, visually you see that dot is missing, right? So then you know it's it. So this is very important, okay? We'll see. I would rather you learn about types when we do something. So I don't want to make everyone memorize all the types right now, right? Just start doing stuff and I'll introduce more of the typing as we go along, okay? Okay, so the next thing is some properties of arrays, right? So we know how to create arrays by now. We know how to create arrays with specific elements. We know how to create arrays with random numbers in them. So we're good. We can create all kinds of NumPy arrays. Now we can ask what are properties of arrays. And the important properties are dimensions, right? How many, so ndim is going to tell us, so right now we've done one-dimensional array, but we can do multi-dimensional arrays. We will talk about them a little bit more soon. So once they have multi-dimensional, you can ask what is their shape, what is their size, what is the D type, and what is the size of each item in the array, okay? And here's a little printout that I've done for you, right, with some array. So you can just play with this code and you can see that you can extract all these properties. So the important thing here is when I previously passed size equals 10 or million or something, instead of passing a one-dimensional object, if I pass in a two-dimensional object, in this case it's 3,3, so it's 9 elements. It's a array with 3 rows and 3 columns. So it's just as easy to create multi-dimensional arrays as it is to create one-dimensional arrays, right? And in some sense, one-dimensional arrays are foundational, right? Multiple array, you can always map a multi-dimensional array to a one-dimensional array by some order of traversal, right? So anyway, NumPy says, fine, just tell me what size you want and what shape you want, and I will take care of it. So this is a very powerful one-liner here, but it also shows you all the properties of the array at the same time. So now we know how to access properties of the arrays. Later we'll have to use these properties in some cases, okay? Then the next thing is, okay, I put all the stuff in the array, now I need to get it out. And of course, what's the way to get it? You use a bracket, right? Use an indexer, indexing operation. So one-dimensional arrays take one index. So that's easy. I didn't do a poll for this, but I assume that all of you understand Python slices. If you don't understand Python slices, what can I say in one sentence? In one sentence, I can say, if you have an array and you pick a start value and a stop value, and you say, I want all the elements within that range. Now you have to be worried about the endpoints, okay? But that's something you're going to find out by trying it out. So for example, here you start from the first element, and the question is the third element included or not? And in Python, the end element, the right-hand side end element is not included, right? So it's closed open intervals. Anyway, that's a short and probably a bad introduction to Python slices, but just because I don't have time to go through basic Python, right? But if you know how to use basic Python slices, you can use slices inside NumPy as well, and it will work. Okay, another one comment I will make about slices and so on. When I first started learning Python, I came from a Java, C#, C++ background. I didn't want to do slices at all. I was like, I don't even need them. But I must say, after writing a lot of Python code now, I use it all the time. It's very Pythonic, and very often we want subsets of a set, and this is a nice way to get that. So it may be worth investing some time if you haven't played with slices before. If you need information, just reach out to me and we can figure it out, okay? But if you know Python already, this is just a recap, so nothing hard here. So that's what I wanted to say about accessing elements. Now, what about multi-dimensional elements? Well, first, let's do this example here. You create a multi-dimensional array. For example, you know, we're getting random numbers from 3 to 9. The size is 3 by 3, right? And I specified them to be integers. Okay, so I got my array here, and you can see some 3 by 3 array here. Now, if you want to get subsets of it, you need 2 indexes. Unlike the one-dimensional case, here we need 2 values to get anything out. In this case, I've actually given 2 slices instead of 2 integers. Right? I could have done 1, 2, then I would have got just 1 element. Okay. So for example, I don't know if that's what's showing even. I hope all of you are able to run this notebook and play around. Okay. And then the main goal would be for you to ask me questions. Okay. I can always show you something, hopefully. For example, you could do 1, 2 if you wanted to, right? You could pass in 2 values and get 1 value out. So if you just want to access 1 element of a multidimensional array, you can do it by passing in the corresponding locations. Now, this should all be familiar if you've worked with any other programming language, so I don't have to spend much time on it, but slices may be kind of unique to, or at least Python was pushing it a lot in the beginning as a unique feature. Now, many other languages have it. Okay. What about accessing a single row or single column? The idea is you can use a colon as the default, right? So if you want you want to get a sub array where all values of the second location are present, then you can just get it like this. I like to think of it as a projection operator, right? So you can put the colon in one of the index locations, populate the other value, and you'll get sub arrays. So again, less I can say in words, but it's important to be easy for you to get in and get out of the NumPy array. Okay. Okay, this is homework for you. I mean, I'm not going to check it, but you should spend some time think about this problem. It's what I'll do in the class is set up the problem for you. When we access elements of an array, do we get copies of the array or do we get pointers to the array? This is a very foundational, fundamental thing, right? Because if you get copies, you're free to do whatever you want. But if you get pointers back to the array, if you modify anything, it means you modify the original array. And so it's a small programming sub-exercise to be clear in your mind when you get copies and be clear in your mind of when you're getting pointers back. Okay, so here I just set up something. Why don't you all make some arrays, get sub-arrays. If you explicitly want to copy things, you can use this .copy a method to make copies and just, somebody asked, repeat the question. So for example, here, if you have an array, so let's look at this example. Suppose A12 is an array. So let's say A12 is an array. Let's make sure it's an array. A12 is an array. Now I take a subset of this array. So for example, let's take this particular subset here. Take the subset of an array. Notice that if you ask me a question, I will go a little bit more into it, right? Otherwise, I'll assume you all know it. Okay, so A12 is a subarray of, no, A12 with these projections in them is a subarray. It's a 2 by 2 array, right? A12, so let's put that up on top of it, escape. So A12 is a 3 by 3 array, and this one is a subset of it. Now, if I do something to an element, if I access something like this, and then I modify these elements somehow, what would happen to the original A12? Does it get modified, or am I getting my own copy here? Is this a copy, or is it pointing back to the original array? That question is very important. It's a very famous source of bugs, right? Where you didn't get a copy or you did get a copy. You have to be clear. And rather than me telling anything, I'm saying, I want all of you to go and try this out, right? Try to get subsets and try to modify them and see if anything behaves differently than what you would expect. Otherwise, you should come back and tell me everything's cool or it's very confusing, and then I can show you more examples, okay? But what I intend to hopefully leave clear in your minds is that when we access arrays, sometimes we don't get copies. Sometimes we get references. And if you get references, then modifying the array, modifying those references will affect the underlying array. Okay, that much said, right? So you have to ask questions more, okay? But now let's go on and say, next thing is filtering, right? Suppose you're given a list of the first 10 elements and you want to extract odd numbers. How do you do it? So let me give you a minute. I'll also get myself some water. Can all of you quickly figure out this? You have 10 elements and you want to extract the odd numbers. Anyone? Okay, in the interest of time, I'm going to forge on to the answer. Okay, so here's the solution basically. You should do this in plain Python as well. It's very simple. So you create a range, and then you can filter it. See how beautiful it is in NumPy, right? You just take, first of all, the odd numbers are defined by taking a division. Take a number and divide by 2 and see if the remainder is 1. If the remainder is 1, then it is odd, right? So this is the condition. This, if you test this with any element of the list, it will return true or false, right? And if you pass this, so escape A, let me see. So we run this. Make sure you ask me more questions, okay? I'm never sure when something is too easy and when something is hard. So let me just show you this anyway. See what happened here when I asked NumPy, is x divisible by 2, is it equal to 1? If I take every element of x and divide by 2 and ask, is it equal to 1? It returns me an array which contains the answer to that question for each element of the list. That's kind of cool, right? It returns a Boolean array, right? An array of trues and falses. And notice, because the array is just linear, 0 to 9, the numbers, this alternates, false, true, false, true, false, true. And now we have a pattern which we will use a lot, especially when we get to pandas. This pattern is, as soon as you have a Boolean array, just like you could pass an integer a slice or an integer number to an array, you can pass a Boolean array to an array. So see how cool this is. This line looks very terse, but what is inside the bracket is actually an array here, right? This thing is an array. And so what it does is, wherever this array has a value true, it will only return those elements where the array has a value true. And it's a tricky and clever idea. And the idea is that whenever you want to filter a list, you create some kind of predicate or a Boolean query that, so for example, if I have a list of students from multiple countries and I want to extract only the students from Canada, then I could say, student.country equals Canada, and then apply that to the list of students somehow. That would give me a Boolean array, because the students it belongs to Canada or does not belong to Canada. And then you can filter the student list by passing this Boolean array to the student list, right? So this has many, many practical filtering applications. Initially, it looks strange and weird. That's why I'm trying to explain in words. But eventually, it will become second nature to you. Whenever you want to get a subset, create a Boolean array and pass it, and then you will get back the subset. So again, not much I can do in words here, but we'll have plenty of examples to think about this stuff. But you should spend some time, think about it, think about these kind of questions. Is using a Boolean array to get subsets, is that confusing? Is that clear? Is that easy? Eventually, I promise you that code like this will be completely straightforward. What, can you ask that question again? What are the conditions in this case? Conditions like what? Give me a little bit more color. Sorry, what is? Okay. So you mean what is the condition? Okay, so let's just go through this. Yeah, good question. So let's go through this carefully. I assume you're asking me about this thing, right? X% 2 equals 1, or no? Yes. Okay. So good. Thanks for asking the question. Keep them coming, so that way I can make sure that you're with me, right? Don't feel any question is too simple. So what is it? So first, let's look at it like this. Let me move this to the side. So first, X is any element of the array. The second part is X%2. X%2 means just take the array and divide it by 2. So in fact, in this case, we can actually just run this. If you run it, you see when you divide by 2, that gives us the remainder when you do %2, right? The basic Python. So if you take any number and divide by 2, either you get 0 or 1. So it tells me quickly whether it's even or odd. Now I want to find out which ones are odd. So I ask, is it equal to 1? So this little line is a quick check of how to find the odd numbers. It's kind of cool, right? Because you would think that in order to find the odd numbers in a list, I would have to write a little bit more code than just this. But it becomes very cryptic, and later it becomes very natural, right? You take the list, you divide by 2, take the remainders, and only get the ones where the remainder is equal to 1. So once you have this criteria, you can pass this criteria now back to the array and say, hey, array, wherever this criteria is true, please give me only those guys. And there you go. I got the odd numbers, right? So is that clear? Slash. So what would slash do? So we should think about that, right? So let's look at this. So if I take x slash 2, what would this do? X slash 2 would just divide, right? And you would get an array which is very different. Just give us the divisions, right? And now if you want to spot the odd ones, it's a little bit more tricky, right? So slash is for division and percent is for remainder. They're two kind of relatives of each other, right? Yeah, no problem. There are no bad questions. I'm sure if you have this question, somebody else has it, okay? And if it takes too much time, we can continue on email. So don't hesitate to ask. They are very useful for us to be interacting. And that's why I'm here and you're here. So good. So notice that this is the simplest thing. Here's a slight, so let me go forward now to slightly more explicit way of doing this. Instead of doing it like this, which I think is cool, you can also explicitly say np.where, and where is like a SQL command. It says, hey, give me everything in the list X where this condition is satisfied. And so, for example, if I want the even numbers, I can find it like this. Or if I want the odd numbers, I can find it like this. And you will decide as a matter of your personal preference whether you like to write the code like this or use np.where. Okay? But these are all very fast things and nice things. Okay? So that's filtering. Now there's another tricky question. What if I want to change the shape of arrays, right? If I have a one-dimensional array and I want to make it into a three-dimensional array or something, then there is this thing called reshape. Now we're getting into some tricky territory, but this stuff will become really important if you start doing analysis or algebra or something like this. So let's just look at reshape quickly. Reshape just says, if I have an array of 30 elements, and I want to convert it into an array of 30 elements. So clearly first condition is that before and after you should have the same number of elements. And then I want to have 3 rows of 10 elements each. So 3 times 10 is 30. And the shape is 3 rows and 10 elements. Then you can pass the new shape to this function called reshape, right? And it takes the one-dimensional array and it reshapes it for you. Okay, and then you get your shape, right? So you can reshape in another direction. For example, I want, 3 columns and 10 rows. So I do 10, 3, right? So it's kind of cool that you can actually mutate or convert arrays into different shapes, right? And you'll find this useful. Similarly, there is this idea of the inverse operation, right? That is, here you have a one-dimensional array. You made it a whatever 10 by 3 array. Now you can go in the opposite direction. If you have a 10 by 3 array and you want to go back to a one-dimensional array, you have 2 ways. Either you can call ravel or flatten. I haven't actually looked into which one is preferred where. Okay, if any of you do find out, you can let me know. But both of them give you this concept, right? That you can actually take multi-dimensional arrays and make them one-dimensional. So these 2 transformations are useful. Okay. Then the next one is, how can I join arrays? If I have different arrays, how can I put them together? And the workhorse there is, of course, like in Python, you can always use plus for lists. It's a concatenation operation. But also NumPy has a faster concat operator. It's np.concat, right? Concatenate. So you pass in a list of vectors. Okay, I'll repeat that again. Concatenate takes a list of vectors. So if you have many vectors and you want to join all of them, you call np.concatenate. Okay, and okay, there's a moral of the story of this stuff that we are discussing today in this class, which is that when you have a package, it's hard for me to kind of teach you, right? You have to do things and explore. But what I'm using this time is to share some concepts, right? Like, okay, one-dimensional arrays, I'd like to make them n-dimensional, right? That's a concept. n-dimensional arrays, I like to make them one-dimensional. That's the concept. So I want you to grab those concepts, and then once this class is over, just sit down with this notebook and try to make each of those concepts into real working code, right? Yeah, somebody asked me about Ravel versus Flattr. Let me look it up and let you know next time, okay? I looked it up a while ago. I've forgotten now, so we can come back and see. But I will say this to you, because of the history of NumPy, there are some cases where the same method is done with two names, okay? But I suspect this is not the case. So I will go look at it. Remind me next time, okay? Hopefully I'll remember. But okay, so concatenate is very important, okay? So often you create arrays and then later you want to put them into a big structure. You collect all the arrays in a list and you call concatenate. Very useful pattern. So this class is about giving you ideas and patterns, right? Actually typing the code and putting the commas in the brackets, you must do on your own. And that's why I keep stressing to all of you, practice is important, right? The programming, and this kind of programming is not just ideas. We have to make everything work, right? The dimensions have to match, the commas have to fit. So there's just a lot of low-level detail, and I cannot lecture those details, right? I can just talk you through it. It's better you do something. If you get stuck, then we can have an interesting conversation. Okay, so please make sure I go through this quickly. Don't say, oh, he went through this quickly, it's a lot, and give up on it. Or say he went through this quickly, it's easy, and underestimate it. Just take some time and try to reproduce everything in this notebook on your own. I think that would leave you in a great place. And maybe you do that a couple of times and all these commands will be things that you can easily recall. Okay, so make sure that all these commands are in your working memory. Okay, and then you'll be very prolific. You'll be able to write a lot of code quickly. Okay, so what did we do? We did concat. Now there's another operation which is similar to concat. It's called stacking. I guess, so for example, if I have two arrays and I want to stack them horizontally, right? So you can take the array x2 and the array y2 and you can actually horizontally stack them. Or you can stack them vertically. So vertically means you put one array on top of the other, vertically going upwards like a skyscraper. Horizontally is like a street, right? You stack them one building next to the other. So that's simple pictorially, but now you just make your favorite array and stack them and see what happens. Okay, so this is the section where we do all of the stacking and concatenation. Then the opposite method, right, is how do I split things, right? And there's this method called vsplit and hsplit, which are kind of siblings of hstack and vstack. They allow us to split the arrays. Okay. Okay, so I think that interestingly is a good minimal set. If you have all this, kind of clear in your mind, you can start doing some fun things with NumPy. Okay, so let's do something quick. Write a function to compute the sum of squares of the elements of a list. So usually, let me just not ask you to do it. Let me talk you through it this time. So you can do this, right? Usually you'll do some kind of for loop, right? Like this, and then you will. So let me talk through. This is straight Python code. You take the list, you create some storage. Each time you square the number, you add it into this list, and then you can calculate sum on it. Right? You'll write code which looks like this, right? And you will see that if you run this kind of code and you time it, it takes some amount of time, right? You can get a little faster if you write, again, Python code which looks like this. But I think there's nothing which beats this code, again, for readability and performance, right? You take every element of the list, you square it, you compute the sum, and you're done, right? And you can see it's 1,000 times faster, right? Or at least 100 times faster, sorry. So yeah, so you should start using NumPy now wherever you can for numerical operations. So how does this become more and more easy for us? Is because there's library functions. So now there's these functions called ufuncs. They can work on vectors, square root, abs, exponential, sine, cosine, etc. Right? They all take one value. Then there are binary functions like add, for example. And here I've given a list to the documentation. Sometime when you feel like it, you can browse. The other way you can use it is you keep the documentation with you when you're working on a project. Whenever you need stuff, a function, you can always look up the documentation, find it, in here, okay? Now, the next thing is you can make your own ufuncs. So here's a good, interesting one. For example, I want to make a ufunc that takes a list and returns all the cubes of all the elements, right? Normally, you cannot do that in Python. But the way we do it is we make this is a ufunc which I can define. The way I've done is I've just used the fact that NumPy can actually cube lists. And so now this thing can actually compute the sum of cubes, for example, okay? And then the next thing here is there's this thing called vectorize. Okay, so this is important. These two examples take some time to study how they're different. Here, I have a simple function that takes a value and returns the cube of the value. Here, I have a function that is actually a, is a NumPy function, right? It returns the cube of elements. So if I have an ordinary function, then I use np.vectorize, and then it will become a vectorized function. So again, you might want to think about this. It's okay. You may not end up writing a lot of code vectorizing things. Okay, you'll always most often be taking advantage of things that are out there. Okay, so I've given you many examples of this. Maybe you can try this out, right? Add all the numbers from 1 to 1,000,000. Try to write it in Python, write it in NumPy, etc. But I had this interesting quip here, which I think is important. You can see the timings at least, right? NumPy is clearly faster. But what is important here is that if you have a good algorithm, so for example, you have this cute little formula for computing the sum of sequential numbers, and that's orders of magnitude faster than anything. So there's a nice hierarchy here that I want all of you to keep in mind, right? Clearly using optimized data structures like NumPy or Pandas will give us speed ups, but that is nothing compared to using a good algorithm. Right? And so we have to know when we are writing code and doing data analysis, when are we going to be optimizing by using a better algorithm versus a better data structure, okay? And they are both in a hierarchy. So there's simple programming challenges here that I've scattered through the notebook. So make sure you spend an hour with this notebook and answer all of them. I'm sure that will give you questions. Come back to me with questions, okay? Here's a section where I talk about aggregates. So for example, max, min, sum, mean, standard deviation, these are all simple NumPy functions. You can always pass a list of values to it and it'll compute, okay? Okay, there's a section here on broadcasting. I know I've been talking a lot, so I'm going to defer this section. For those who are advanced, this may be the section they want to read, but we can come back to this later, okay? Because I understand from your point of view, so I'm saying so many things, how do you absorb it all, right? I wouldn't even expect you to absorb it all. I would expect you to hear it, grab some of the ideas, take some notes, come back and work with this notebook. That's when it'll all become concrete. Pretend you're writing this notebook yourself, and then I think you'll be in good shape, okay? Now, here's another interesting concept. The concept of a record. This is very important. It's like a row in a spreadsheet or a row in a database table. It has a particular structure, right? Like for example, the first entry can be an ID. The second entry could be, I don't know, height. And third entry could be the name. And that is called a record, okay? And in NumPy, you can actually create these records, right? And you can actually store them, right? And create tables out of them. Again, this may be what I put this here with a very clear idea in my mind. I don't think any of us are going to spend too much time doing this kind of work. So that's why I put it here. But saying that creating database tables inside NumPy, probably at that time you might, or I might recommend, or you might choose to switch to Pandas, which is coming next class, right? So there you'll get a lot more ways to do data analysis that mirrors, spreadsheets and database tables and all these kind of ideas, right? So that'll take this to the next level. Okay, so now let's do some small applications here that might be nice. I think when we were in school and some early college, always a question, right? You're given linear equations and you're asked to solve them, for example. I want to show you just in a couple of lines, how does this all become very powerful, right? So you have 3 linear equations, you have to solve them. I think all of you must have done spent plenty of time on doing all this. I certainly did. And there are ways to do it, either by elimination, by hand, or by using matrix algebra. So let's just use matrix algebra to solve this set of linear equations, right? So the linear equation, when you write it in matrix form, again, if you have questions, you may ask, but I'll assume all of you know some linear algebra. So this can be written as a matrix equation, right? Where all the coefficients are in this matrix A, and it multiplies a vector X, and A times X is equal to Y, and Y is the elements on the right-hand side, right? So you can do this, solving this equation in like 3 lines, right? So you create an array which has the values, you reshape it to be a 3 by 3 array. So that gives you A. Then you have the value Y, which is the thing on the right-hand side, and you're trying to solve for X, right? And so you know the solution here. This is the solution to this problem, right? You compute A inverse and multiply multiply Y with A inverse, you will get X, right? So in other words, the definition of A inverse is A times A inverse is equal to 1. So okay, it's basically in the algebra, right? So you left multiply with A inverse, you get this. But now you can do all this very easily, right? You just say inverse of A dot Y. That's the NumPy solution to this problem, right? And you should just play with this. And at least I was smiling to myself because I spent so many hours trying to do all this by hand, and now it's just like 2 lines of code. And I think that is what we are trying to access through this discussion of NumPy, right? That we get a gateway to optimize data structures, and then a gateway to interesting algorithms. In this case, how to compute inverses and how to solve linear equations, right? And it's kind of amusing for all of you to ponder that, you know, a major subsection of linear algebra, how to solve linear equations, multidimensional linear equations, can be in a one notebook, and then you can start asking about all the deeper insights and edge cases here. Okay, so spend a moment on this. I also want to spend a minute here. Maybe this is mildly interesting for all of you. Look at this problem quickly. I'll give you a minute to read the problem statement. The problem statement is up here. So read this quickly. So, okay, so now, okay, so simulate a million rolls of a pair of dice, right? So think about that for a second. How easy does that sound and how hard does that sound? At least to me, I would say before my programming days, when people gave me questions like this, it was like, oh, that would be nice if I could do it quickly. But I don't want to sit and write 10 pages of code to simulate a pair of dice. Okay, so now let me state the question even more precisely, so we'll get interested in the answer. So here's a question. You can try to play with your friends. You take 2 die, right? The normal dice that we use, and you're betting on the outcome, which is the sum of the values on each of the dice. So let me see if all of you are awake and with me still. What is the minimum you can get if you roll 2 dice? Minimum value you can get for the sum? Someone on chat. I have 2 dice and I roll them. What's the minimum value you can get? 2. Ah, cool. Yeah, you're all awake and with me. Thank you. Okay, so what's the maximum I can get? 12, right? So the answers are between 2 and 12. That's awesome. That's good that you guys are with me now. So now the question is, I'm going to bet on the outcome of the sum. And I'm going to ask you to pick a number. What number would you pick? So the human intuition, or most people's intuition, is, well, it's a die. Any number is equally probable. So why not? I just pick at random. And it's, yeah, it's actually not true, right? There are special numbers. Some of you start guess the middle numbers. Now, as soon as you guess the middle numbers, we would like a kind of proof of that, right? And that's what this question is asking. Can you prove to me that a particular number may be more interesting than the other? So, of course, I've written the code and I'm showing you the answer. There's a nice little graph. And my point to all of you is the analysis is only 4 lines of code, right? So it makes it all blazingly clear and easy, and we should go home feeling powerful, right? That I can ask a question like that and I can answer it before I use all my gray cells by just running something and just look at this graph, and you see the peak is right in the middle, right? It's not at the tails. Then you come back with an explanation. Well, there are more ways to get the number, 7 by combining 2 die, blah, blah, blah. And you understand your probability and your probability distribution and all those kind of things. But it's so nice that we can just write a simple simulation. So let's look at the simulation quickly and see how easy it was. And the answer is, well, I want to simulate 1 die. So the numbers go from 1 to 7. 7 is not inclusive, so I'll get 1 to 6. I want to simulate them 1,000,000 times. So this is actually fairly robust. I'm not just doing 5 rolls. And then you take the same copy of that, right? There's 2 dice. And now I want to add them and look at the value of adding them. So that's what I do. I take the 2 die values, I add them. You see here, it's just 1 line to add up the values. And then I put it into a histogram. Now, this picture and this histogram I saved for the tail end of our course. So we're going to spend one whole class just making different types of charts. So you can tell me all your interesting ideas about visualization, right? But visualization for me is a very cool subject and very important subject, because I do believe that a picture is worth 1,000 words, right? Here you can quickly see what is going on if you can get a picture, much better than looking at reams of data. So anyway, the point is, please think of this like a small piece of poetry in code, right? It's only like 6 lines and it answers a nice little question. I hope you liked it. But now it's been about an hour and a half. I'm sure all of you are getting tired. So maybe time for me to start winding down. Do you have any questions for me? Okay, I have a question for you. Let's see if this poll will work. Can you guys take this poll for me quickly? I'll put a poll on the screen. Let's see. Can you see it? Or maybe you can't see it. Can someone tell me? Can you see the poll on your screen or no? Ah, you were able to vote. Okay. Usually it should show me updates, but I didn't see any updates. Did you get a button to click on? Yeah. Okay, let me see what happened. Those were going to. Yeah, I didn't get any updates for some reason. Okay, so maybe it's not even working. Okay. Yeah, somebody had a question for me. When practicing today's lesson, do you recommend just going through and playing with the current commands? Do you have an exercises we can practice? Okay, so the exercises are coming, right? So in particular, yeah, the exercises are coming. In particular, this first lab that somebody asked me a question for, I will update the due dates on it. That lab will give you a chance to practice the SQL stuff. And then every class from now on, we will have a lab to work on, right? And in the lab, you can get to do more exercises, okay? But I would say for now, don't worry so much. I want this course also to encourage you to ask questions, right? I really want to say this is very important transition for all of you. Like, we spend a lifetime as students learning things where our job is to come up with the answers. But in life, you're going to find that your job is to come up with questions, right? And I think that is an important transition. So I want this course to be part of the transition for all of you, right? You must come up with questions, right? And I will provide you with the tools to answer interesting questions. And this kind of builds to a climax when you do your project, right? Your project is very open-ended. So you get to pick any topic of your choice and do some data analysis on it, right? So I want to remove the scaffolding, and I want to be less the instructor who's chasing all of you to finish your labs. I want all of you to take initiative. And the reason for you to do all this is because there's tremendous benefits waiting for all of you in good, lucrative, and interesting careers, right? If you can control and understand these ideas and write good programs, you have so much to benefit, right? So rather than me chasing all of you and say, do your homework, I would love all of you to come up with, hey, I have this interesting question and I'm trying to solve it, and start writing code from your own initiatives. But having said all that, yes, there will be labs and I will give you exercises. Okay, and at the very minimum, I'm saying that the notebook is set up in a way that you could actually use it for practice. Just erase everything I've written and try to recreate. Okay, if you can do that, I think you already find yourself in a good place. And I must tell you that periodically when I have need to in the past to learn NumPy or something, this is how I learn it. I make a notebook like this and I write everything myself, right? So that gives me time to think about what is the ideas, how do I do it, what is the connection between H stack and V stack or whatever, some detailed thing like this. Just work with a notebook like that and then save the notebook so that after a week or 2 weeks when you've forgotten everything, all you have to do is just open the notebook and refresh your memory of it, right? And if you do that, while this course is on, I think you will come out of this course feeling very comfortable that you can actually do some analysis, you can manipulate data, you can ask interesting questions, and you can solve them. Okay, so more questions. So I hope I answered your question, Alex. Alex, yeah. But yes, any other questions? Okay, if there are no more questions, then maybe we will wind up today, and I will send out an email. I'll make sure that the deadlines for the labs are far out enough, so don't have to worry. And if I need to, work with you on it, I'm happy to. Please be proactive. Send me email, ask questions. Anything you ask is fine. And I will see you all next week. And next week we will start doing pandas. Okay, so these are two. So notice how we're going. We first did SQL, which is the good old way of handling things. Today we did NumPy, where I started to introduce concepts like how to get performance, how to do these modern looking fast computations using NumPy's libraries. The next class is kind of an iteration on this. Pandas builds on top of NumPy and gives you much more tools to do data analysis, right? So the next 2 sessions we will spend on pandas. Hopefully we'll have more interesting exercises for you, and eventually you can start working on your project as well. But okay, so much for today. Any other questions? If not, then I'll let you go and enjoy the rest of your evening, and I'll talk to all of you soon. Thank you.